What if you woke up tomorrow and realized everything you thought was real was just one tiny slice of reality? Picture this, a version of Earth where dinosaurs never went extinct, where you could step outside and see a towering T-Rex strolling past your local coffee shop. Or a universe where you never existed at all and someone entirely different lived your life instead. Sounds like science fiction, right? But here's the wild part. Science says these alternate realities might not just be fantasies. They could be out there right now, hidden in the fabric of the cosmos. This is the mind-bending world of parallel universes, where every choice, every chance event spins off a new reality. And the craziest part, there could be 25 of these universes, maybe even more, existing alongside ours, each with its own set of rules, its own history, its own version of you. You've seen this idea teased in shows like Rick and Morty or movies like Doctor Strange, where characters hop between dimensions like tourists flipping through vacation photos. But the real science behind the multiverse theory is even stranger than anything Hollywood could dream up. Physicists and cosmologists aren't just guessing. They're piecing together equations, observations, and wild yet plausible theories that suggest our universe might be one bubble in an endless cosmic froth. Some universes could have laws of physics so different, matter itself behaves in ways we can't even comprehend. Others might mirror ours almost exactly, with only tiny, eerie differences, like a world where your favorite color is blue instead of green, or where history took a sharp turn because a single raindrop fell differently. So why does any of this matter? Because it forces us to ask the biggest questions of all. Are we alone? Is reality as fixed as it seems? And what does it mean for us if infinite versions of our lives are playing out somewhere else? Strap in, because we're about to dive deep into 25 of the most jaw-dropping parallel universes that could exist right now. From worlds where gravity works backwards to realities where time runs in loops. By the end of this journey, you might never look at your own life or the universe the same way again. Ready to take the leap? Let's go. Imagine opening a box, not just any box, but one that holds the fate of a cat inside. You've probably heard of Schrödinger's famous thought experiment. A cat in a sealed box, simultaneously alive and dead until you peek inside and force reality to pick a side. But what if that moment of observation doesn't just reveal one outcome? What if it splits reality itself? That's the spine-tingling premise of the many worlds interpretation, the first and most startling parallel universe on our list. According to quantum physics, every time a particle faces a choice, like whether to spin left or right, or whether that cat lives or dies, the universe doesn't decide. Instead, it branches. One path continues with a purring cat, another diverges with a tragic meow, and here's the kicker, both are equally real. This isn't just wild speculation, it's a theory backed by hard math, pioneered by physicist Hugh Everett in the 1950s. While classical physics treats the universe like a clockwork machine, ticking predictably forward, Everett dared to ask, what if every possible quantum outcome actually happens? His equations revealed a cosmos that constantly fractures, like a hall of mirrors reflecting endless variations of reality. Take something as simple as flipping a coin. In our world, it lands heads up, but according to many worlds, there's another universe where it landed tails, and another where it never landed at all, hovering in midair as gravity briefly glitched. Critics argue this sounds more like philosophy than science, but here's where it gets empirically fascinating. Quantum particles already behave in ways that defy single reality logic. Electrons exist in multiple places at once until measured, a phenomenon called superposition. Many worlds simply takes this further, suggesting superposition never collapses. Instead, we split along with the particles, each version of us unaware of the others. You're reading this script in one universe, while in another you clicked off to watch cat videos. And somewhere out there, a version of you is living the life you almost chose, the job you didn't take, the person you didn't marry, all equally valid, all unfolding in parallel. So why doesn't this feel like chaos? Because these branches don't interact. They're like channels on a cosmic radio, playing simultaneously but tuned to different frequencies. Hugh Everett's work was initially dismissed as too radical, but today it's gaining traction as a solution to quantum mechanics' biggest puzzles. It paints a universe, no, a multiverse of staggering possibility, where every choice, every accident, every quantum roll of the dice spins off a new world. And if that's true, then somewhere out there, a version of you is already living the wildest what-if scenario you've ever dreamed up. Picture the Big Bang not as a single explosion, but as the first bubble in a boiling cosmic kettle. This is the heart of the bubble universe theory, the idea that our entire cosmos might be just one radiant orb floating in an infinite sea of others, each with its own rules, its own version of reality. Think of soap suds clinging to the edge of a sink. Some bubbles are tiny, others vast, and every one exists independently, barely aware of the others. Now scale that up to universal proportions. What if the universe we call home is just one frothy pocket in a multiverse that never stops expanding? The math behind this idea comes from inflation theory, which suggests that in the first sliver of a second after the Big Bang, space itself expanded faster than light, a runaway stretching that could have created not just our universe but countless others. Like a baker pulling apart cosmic dough, this hyper-expansion might have left behind isolated pockets where physics settled into different configurations. One bubble could have stronger gravity, making stars burn out in days. Another might have no weak nuclear force, preventing atoms from forming at all. The unsettling truth, we're stuck inside our bubble, unable to see beyond its edges, like goldfish unaware of the ocean outside their bowl. But here's where it gets even wilder. These bubbles aren't necessarily static. They drift, they jostle, and sometimes they collide. Scientists scour the cosmic microwave background, the afterglow of the Big Bang, for odd wrinkles or temperature spikes that might be scars from a long-ago brush with another universe. Imagine waking up to find a bruise on your arm with no memory of how it got there, except this bruise is stamped across the sky, a ghostly handshake from a neighboring reality. While we haven't found definitive proof yet, the search itself reshapes how we see existence. Our universe might not be a solitary masterpiece, but one brushstroke in a multiverse mural too vast to comprehend. And that raises a haunting question. If bubbles can collide, could they also pop? Is our universe's fate tied to something as fragile as a membrane of spacetime? The bubble theory doesn't just rewrite our origin story. It hints that reality might be far more fluid, far more precarious than we ever dared to believe. Close your eyes and picture the universe not as a vast emptiness dotted with stars, but as a vibrating guitar string, each delicate oscillation humming a different note, a different reality into existence. This is the dazzling vision of string theory, where the very fabric of spacetime isn't made of particles, but of unimaginably tiny strings wriggling through 11 dimensions. And if that sounds trippy, hold on, because this theory doesn't just describe our universe. It predicts a staggering 10 to the power of 500 possible others, each with its own unique tune of physical laws. That's not a typo, 10 with 500 zeros after it, a number so colossal it dwarfs every atom in our observable cosmos. So how could so many realities hide in plain sight? The answer lies in dimensions we can't see. Think of space like a sprawling city. We're familiar with the street's length, width, height. But what if every building had secret rooms folded inside, too small to notice? String theory suggests 6 extra dimensions are curled up like microscopic origami, tighter than an atom. And here's the kicker, how they're folded determines everything. Gravity's strength, the speed of light, even the existence of atoms all depend on these hidden geometries. Tweak the folds just slightly, and you'd get a universe where stars ignite in seconds or where matter crumbles like wet sand. It's like a cosmic piano with 10 to the 500 keys, each playing a different version of reality. Now imagine you're tuning an old radio. A hair's breadth turned dials in static, another lands on a jazz station, the next crackles with a news broadcast. String theory's landscape works the same way. Each station is a self-contained universe with its own constant, its own unique settings for gravity, electromagnetism, and the other forces. Some stations might be dead air, universes so unstable they collapse instantly. Others could host life, but under rules wildly different from ours. Physicist Brian Greene likens it to a cosmic lottery. We just happen to win the jackpot, landing in a universe where the dials are set just right for galaxies, planets, and us. But there's a mind-bending twist. If all these universes exist, why don't we see them? Think of ants crawling on a tree trunk, unaware of the forest around them. Our entire cosmos might be one leaf on an infinite tree, with other realities fluttering out of reach. Some scientists even speculate that these universes could brush past each other, leaving faint imprints like echoes of a Big Bang that wasn't ours. While we haven't spotted direct proof yet, projects like the Large Hadron Collider are hunting for clues, from extra-dimensional particles to ripples in spacetime's fabric. String theory's landscape is more than science, it's philosophy with equations. It asks whether our universe is inevitable or a fluke in a multiverse where every possible set of laws plays out. And if that's true, then somewhere in that vast ensemble, there's a universe where strings vibrate just differently enough to make you a creature of pure energy, or where time flows sideways. The scariest part, we may never know for sure, trapped inside our own tiny, vibrating slice of the symphony. What if everything you see, touch, and feel, the warmth of sunlight, the taste of chocolate, even the ache in your muscles after a long day, isn't real at all? Not in the way we think, anyway. Enter the simulation hypothesis, the fourth jaw-dropping parallel universe on our list. This isn't the plot of The Matrix, it's a serious scientific and philosophical argument that our entire existence might be nothing more than lines of code in some unfathomably advanced computer program. And if that's true, then other universes could simply be different simulations running on the same cosmic hard drive, like open tabs in a browser we can't see. The idea traces back to philosopher Nick Bostrom's infamous trilemma, which lays out three unsettling possibilities. 1. Almost all civilizations at our level of technology go extinct before they can create realistic simulations. 2. If they do survive, they likely lose interest in building ancestor simulations, digital recreations of their past. But the third option, the one that keeps thinkers up at night, that we're almost certainly living in a simulation ourselves. Why? Because if even one advanced civilization ever runs countless simulations of their history, the odds say you're far more likely to be one of the simulated minds than the original. Billionaire futurist Elon Musk put it bluntly, "The chance we're in base reality," he says, "is 1 in billions. But how would we even know? Think about the video games we play today. A century ago, pixels were unthinkable. Now we've got VR headsets that trick your brain into believing you're climbing a mountain or dodging bullets. If we can create immersive worlds with primitive 21st century tech, what could a civilization a million years ahead of us build? Glitches in our reality, déjà vu, missing socks, even quantum particles behaving unpredictably might just be bugs in the code. Some scientists even argue that the universe's resolution has a limit. Planck length, the smallest possible unit of space. Sound familiar? It's exactly how a simulation would conserve processing power. Here's where it gets truly dizzying. If we are in a simulation, whoever's running it might be in a simulation too, a cosmic stack of virtual realities, each nested inside the next like Russian dolls. The original real universe could be buried so deep it's lost forever. And if other simulations are running alongside ours, they might have entirely different physics, histories, or even objectives. One could be a historical recreation, another an alien's art project, and another, well, a failed experiment left running in the background. So should we panic? Not necessarily. Even if we're living in someone else's software, this universe is real to us. The love you feel, the dreams you chase, the mysteries you unravel, they all matter regardless of their substrate. But the simulation hypothesis does something extraordinary. It forces us to question the very nature of existence, and until we find proof or a system update notice, the question lingers like static in the back of our minds. Are we the players, the played, or something stranger still? Flip your hands in front of a mirror and you'll notice something peculiar. Your reflections left and right sides are reversed, but the rest stays identical. Now take this simple thought experiment and scale it up to everything in existence. Welcome to the mirror matter universe, a shadow realm where particles are perfect inverted copies of our own, obeying the same laws of physics, but flipped like a cosmic photo negative. Here, atoms spin the opposite way, time might flow backward, and your mirror self could be sipping coffee with their left hand while their heart beats on the wrong side of their chest. This isn't just a funhouse illusion, it's a serious hypothesis that could solve one of astronomy's biggest mysteries, dark matter. Scientists know invisible something makes up 85% of the universe's mass, bending galaxies like invisible hands shaping dough. But after decades of searching, no one's found it, unless, of course, it's been hiding in plain sight, or rather, hiding in mirror sight. If mirror matter exists, it would interact with our world almost exclusively through gravity, like a ghost walking through walls. That would explain why our detectors, built to catch familiar particles, keep coming up empty. Picture two parallel cities sharing the same space but built on different blueprints. In one, cars drive on the right. In the other, they glide silently on the left, their passengers never aware of each other. That's how mirror matter could coexist with us, same universe, different versions of reality. Even wilder, the Big Bang might have created equal parts matter and mirror matter, but through some ancient cosmic quirk, our version dominated. Yet remnants of that mirrored twin could still linger, woven into the fabric of space, tugging at stars with unseen fingers. The implications get stranger. If a mirror Earth exists, it wouldn't just have left-handed doppelgängers, it might have entirely inverted biology. Proteins could spiral the opposite direction, making mirror life incompatible with ours on a molecular level. A virus from their world would be as harmless to us as a snowflake, and vice versa. Some theorists even speculate that mirror matter could explain eerie phenomena like spontaneous human combustion or ball lightning, fleeting moments when the veil between versions thins. So how do we find proof? Scientists are hunting for celestial oddities, stars that burn too cold, planets that warp light too much, hinting at mirror objects hiding in the cosmos. Others are tuning ultra-sensitive detectors, hoping to catch the faintest whisper of a mirror particle brushing against ours. If they succeed, it would rewrite our understanding of reality itself. Not as a solo act, but as a duet, two universes dancing in the dark, forever close, forever separate, each the other's reflection. History books tell us the past is fixed, etched in stone, unchangeable. But what if time isn't a straight line at all? What if it's more like a sprawling tree, with every decision, every accident, every twist of fate sprouting a new branch, a whole new universe where events unfolded differently? This is the time-branched universe, a reality where history isn't written in ink, but in endless drafts. Picture a world where the Library of Alexandria never burned, preserving ancient knowledge that could have accelerated human progress by centuries. Or one where a single missed telegram allowed Archduke Ferdinand's car to take a different route, preventing World War I before it began. These aren't just thought experiments, they're glimpses into parallel timelines that could exist right now, each born from a single pivotal moment. The science behind this idea ties into something called quantum decoherence, the same phenomenon that makes Schrödinger's cat both alive and dead until observed. But instead of microscopic particles, imagine entire civilizations in superposition. Take World War II. In our timeline, the Allies triumphed. But according to the time-branched model, there's another universe where Nazi Germany developed the atomic bomb first, or where D-Day failed, leaving Europe under permanent fascist rule. These alternate histories aren't fiction, they're potential realities playing out in pockets of the multiverse we'll never see. Films like Back to the Future play with this concept, showing how tiny changes, like preventing your parents from meeting, could rewrite everything. But real physics suggests these branches wouldn't just alter personal lives, they'd reshape geopolitics, technology, even evolution itself. Now, here's where it gets paradoxical. If time branches endlessly, could you theoretically go back and kill your own grandfather, preventing your birth? Classic time travel logic says no, you'd create a contradiction that unravels reality. But the time-branched universe offers a chilling solution. You wouldn't erase yourself. Instead, you'd spawn a new timeline where your grandfather dies young, and you simply never exist there. Meanwhile, the original version of you still gets born in the universe you left behind. It's like deleting a file on your computer, only to realize it's still safe on the cloud, a backup history untouched by your meddling. Some physicists argue this isn't just theoretical. Evidence might hide in the cosmos's fine details, statistical flukes in cosmic background radiation, or particles behaving as if they've crossed over from nearby timelines. Others suggest déjà vu could be fleeting glimpses of alternate versions of ourselves experiencing similar moments. Whether or not we ever prove it, the time-branched universe forces us to confront a humbling truth. Every choice we make, every chance event, might not just change our future, it could spin off an entirely new world, forever diverging from our own. And somewhere out there, another version of you is living with the consequences of the path you didn't take. Take your smartphone and tilt it under the light. Watch how the screen seems to hold layers of depth despite being utterly flat. Now stretch that concept to the universe itself. What if everything around us, the mountains, oceans, even the stars, aren't truly three-dimensional objects but an elaborate illusion, a cosmic magic trick played on the grandest scale? This is the holographic universe theory, a mind-crunching idea that suggests our reality is nothing more than a projection, like a movie playing on the surface of an unseen cosmic screen. And if that's true, other universes might just be different films encoded on separate two-dimensional planes, stacked like DVDs in a celestial library. The math behind this comes from black holes, those space-time warping monsters that shred matter into oblivion. In the 1970s, physicist Jacob Bekenstein made a startling discovery. The information swallowed by a black hole isn't destroyed. Instead, it gets smeared across its event horizon, the point of no return, like graffiti on a cosmic wall. Later, Leonard Susskind and Gerard T. Hooft took this further, proposing that all information in the universe could be similarly encoded on its outer boundary. Think of it like watching a football game on TV. The players, the crowd, even the blades of grass aren't actually inside your screen. They're reconstructed from flat, pixelated data. Our reality might work the same way, with every atom, every thought, every galaxy merely a hologram projected from the universe's edge. Now here's where parallel universes creep in. If our cosmos is a hologram, who's to say there's only one screen? Imagine a vast cosmic multiplex where each universe is its own film reel, playing different versions of existence. One could be nearly identical to ours, with slight variations, perhaps a world where the hologram glitches, making gravity 10% weaker or light slightly redder. Another might be utterly alien, with physics so distorted, time loops like a broken record. The holographic principle even suggests these screens could interact, data leaking between them like radio interference, creating eerie overlaps. Have you ever seen something out of the corner of your eye that vanished when you turned? Some theorists wonder if those could be fleeting glimpses of adjacent holograms brushing against ours. But how do we test something so abstract? Scientists are hunting for pixelation in spacetime itself. Just as a digital image breaks into squares when zoomed too far, the universe might reveal a fundamental graininess at the tiniest scales, evidence of its holographic code. Experiments using gravitational wave detectors and particle colliders are searching for these telltale jitters, like archaeologists sifting for fossils of the cosmic projector. If they succeed, it would mean reality as we know it is no more solid than a shadow dancing on a cave wall. And somewhere beyond that wall, infinite other shadows flicker, each telling a different story of what could have been or what might still be. We think of beginnings and endings as fixed points, the Big Bang bursting into existence, the heat-death of the universe fading into silence. But what if death isn't the end? What if the cosmos doesn't die so much as reincarnate, collapsing and exploding in an endless cosmic heartbeat? This is the cyclic universe theory, a vision of reality where universes don't just exist, they repeat, like a grand symphony played on loop across eternity. Imagine stretching your hands toward the sky, only to realize the stars above are the remnants of a universe that came before ours, its ashes recycled into new galaxies, new life, new stories. At the heart of this idea is renowned physicist Roger Penrose and his conformal cyclic cosmology, an elegant, if mind-bending, model where the distant future of one universe becomes the Big Bang of the next. Picture an old vinyl record. As one song ends, the needle lifts, resets, and drops again. But here, the needle is the entire fabric of space-time. As our universe expands toward heat-death, where all energy dissipates, black holes evaporate, and even atoms decay, something extraordinary happens. Space becomes so vast and empty that time loses all meaning. Distances stretch to infinity, temperatures even out, and the universe forgets its own scale. At this point, Penrose argues, the end of time mathematically mirrors the conditions of the Big Bang itself. Like a snake eating its tail, the cycle begins anew. Black holes play a starring role in this cosmic rebirth. These gravitational monsters don't just vanish, they slowly leak energy via Hawking radiation over eons. But according to Penrose, the information they swallowed isn't destroyed. Instead, it's encoded in the fabric of space-time, like a message in a bottle tossed into the next universe. These Hawking points could imprint the new cosmos with faint echoes of its predecessor, ancient fingerprints on the cradle of a new reality. Some scientists even search for these marks in the cosmic microwave background, hunting for circular patterns that might be relics of a universe long gone. What would a cyclic cosmos look like in practice? Consider a library where every book tells the same core story, but with altered details. A twist in Chapter 3, a different hero in Chapter 7. Each cycle might have galaxies, stars, and planets, but arranged differently. One universe could be dominated by supermassive black holes colliding in a cosmic ballet. Another might birth life forms adapted to a slower, colder expansion. And if Penrose is right, our universe isn't the first iteration nor the last. We could be living in the 50th cycle, the 1000th, or one in an infinite series, each reboot rewriting the laws of physics just slightly. The implications are staggering. If universes recycle, then everything we know, every law of nature, every constant might not be fundamental truths, but local bylaws specific to this cycle. The speed of light, the strength of gravity, even the structure of atoms could shift in the next iteration. Some theories suggest dark matter itself might be residue from a previous universe's collapse, ghostly dust clinging to the new one. And while we can't see beyond our own cycle, the mere possibility reshapes how we view existence. Time isn't a straight line, it's a spiral, winding through eras we'll never witness toward futures we can't imagine. So what's left when the music stops? If the cyclic universe holds, the answer is simple. The music never stops. It just starts over with a new arrangement, a fresh crescendo. And somewhere in that endless rhythm, another version of you might be gazing up at the night sky, wondering just as you are now, if the universe has done this all before. Out in the infinite cold of empty space, where time stretches into eons and atoms drift further apart than you can imagine, what if a single, conscious brain suddenly flickered into existence completely alone? Not attached to a body, not born of evolution, but assembled purely by chance from the random jostling of particles in the void. This is the Boltzmann brain paradox, one of the most unsettling ideas in physics. A thought experiment that asks whether your sense of reality might be nothing more than a temporary glitch in the cosmic noise. The paradox gets its name from 19th-century physicist Ludwig Boltzmann, who first grappled with a bizarre implication of entropy, the universe's tendency toward disorder. Given enough time, even the most improbable events must happen occasionally. A deck of cards shuffled forever will eventually produce a perfect royal flush purely by accident. Now extrapolate that to reality itself. In an eternally expanding universe, particles bouncing around at random could, against all odds, briefly arrange themselves into a fully formed, self-aware brain. Not a brain with memories or a past, but one that thinks it does. One that wakes up convinced it's a person living in a world with friends, a history, even a YouTube video playing only to dissolve back into chaos nanoseconds later. Here's where it gets personal. If Boltzmann brains are possible, even statistically inevitable over infinite time, how do you know you're not one? Your entire life, your childhood memories, even the device you're watching this on right now could be an elaborate hallucination conjured by a lone, disembodied brain floating in nothingness. Philosopher Nick Bostrom once pointed out that the number of potential Boltzmann brains in an eternal universe vastly outnumbers real, evolved minds like ours. So by sheer probability, you're more likely to be a momentary flicker of false consciousness than an actual human. Scientists recoil at this idea not because it's impossible, but because it makes empirical knowledge meaningless. If reality could be an accidental daydream, how can we trust any observation? Some physicists argue the paradox actually undermines theories that predict eternal expansion, like the multiverse. Others suggest our universe's improbable order hints we're in a bubble where low entropy conditions make real, stable observers possible, not just fleeting Boltzmann flukes. Yet the question lingers like a whisper in the dark. What's more real, the universe we perceive, or the unsettling possibility that all of it, every star, every law of physics, even the notion of time, is just an illusion spun by a lonely mind that won't exist long enough to realize it's alone? The Boltzmann brain doesn't just challenge cosmology, it forces us to ask what consciousness is when stripped of everything we take for granted. And until we solve it, every moment you experience comes with a ghostly footnote. Are you sure this is real? Right now, as you watch this, an invisible force is stretching the universe apart, not just expanding it, but accelerating that expansion faster and faster with each passing second. This mysterious push is called dark energy, and it makes up 68% of everything in existence. But here's the terrifying part. If dark energy behaves just slightly differently than we think, it could do far more than push galaxies apart. It could shred space-time itself, splitting the cosmos into countless isolated fragments, each a self-contained universe, forever cut off from the others. This is the dark energy multiverse, a future where reality doesn't branch by choice or chance, but gets torn apart by the very fabric of space. Imagine blowing up a balloon with tiny dots on its surface. As it inflates, the dots drift apart. Now, picture the balloon stretching so fast that the rubber between the dots thins to nothing, leaving each dot floating in its own tiny bubble. That's the fate awaiting our universe if dark energy's strength increases over time. Galaxies wouldn't just recede from view, they'd vanish entirely, their light unable to cross the widening gaps as spacetime rips at speeds faster than light. Civilizations would wake up one cosmic morning to find the rest of the universe gone, leaving them alone in an island of stars destined to burn out in solitude. Physicists call this the Big Rip scenario, and the math behind it is chillingly straightforward. Dark energy's repulsive force could grow so dominant that it overcomes gravity, electromagnetism, even the nuclear forces holding atoms together. First, galaxy clusters would be yanked apart, then individual galaxies, then stars. In the final moments, planets would disintegrate, molecules would unravel, and space-time itself would fracture into quantum foam, a froth of disconnected micro-universes, each a frozen snapshot of what once was. Some theories suggest this process might have already happened elsewhere, meaning our observable universe could be one of countless remnants drifting in the carcass of a larger, long-dead cosmos. But here's the twist: while this sounds apocalyptic, it might also be creative. Just as steam bubbles form in boiling water, these space-time ruptures could birth new pocket universes, each with its own physics. Some might collapse instantly, others could stabilize with slightly different constants. And if inflation theory is right, these bubbles could inflate into full-fledged universes, complete with their own dark energy, their own galaxies, their own doomed civilizations. It's a haunting echo of the cyclic universe, but without rebirth, just endless fragmenting solitude. So how close are we to this fate? Current measurements suggest dark energy's strength is constant for now. But if it's even slightly variable, the countdown could already be ticking. In 100 billion years, the Milky Way might be the only galaxy left in our sky. Then the stars will wink out one by one, their light stretched into useless infrared whispers, and long after the last black hole evaporates, space-time itself might come undone. The eerie beauty of this theory is that it turns the universe's death into a strange kind of reproduction, an infinite swarm of cosmic stillborns, each carrying the faintest memory of a shared origin. The dark energy multiverse doesn't just predict the end. It asks whether endings are ever truly final, or just the start of something too fragmented, too alien for us to recognize as kin. Numbers don't just describe reality. What if they are reality, not just the language of the universe, but its very substance? This is the radical core of the mathematical universe hypothesis, where the cosmos isn't governed by math, it is math, an intricate structure of abstract relationships wearing the mask of stars, atoms, and human thought. Physicist Max Tegmark takes this idea further. If math exists independently of human minds, then every mathematically possible structure must exist somewhere. Not as a simulation, not as a physical object, but as a universe in its own right, as real to its inhabitants as ours is to us. Think of a chessboard. We know the rules: how bishops slide diagonally, how pawns advance, but imagine a game where those rules change. Knights teleport 3 squares instead of 2, queens move like checkers. The mathematical universe hypothesis suggests our universe is just one possible rule set in an infinite library of games, each playing out in its own cosmic arena. And here's where it gets dizzying. Some of those rule sets might be unrecognizable to us. A universe where circles have sharp edges, where time has 7 dimensions, or where 2 plus 2 equals 5, not because of a glitch, but because its math fundamentally behaves differently. Tegmark divides this multiverse into 4 levels, each wilder than the last. Level 1, distant regions of space with the same physics as ours but different initial conditions, like a cosmic reshuffling of matter. Level 2, bubble universes with distinct physical constants, as we've explored earlier. Level 3, the quantum many worlds branching with every decision. But level 4, that's the mathematical universe in full glory, a domain where all coherent mathematical structures exist as physical realities, not just variations of our physics, but systems so alien they defy visualization. Could a universe exist where basic arithmetic fails? Surprisingly, yes, if it operates under modular arithmetic, like clock math, where 12 hours later, 3 plus 9 loops back to 0. In such a world, counting wouldn't be linear. Numbers might wrap around like a Möbius strip. Creatures there would think of 2 plus 2 equals 1 as naturally as we accept gravity. Their physics, their logic, even their intuition would evolve to match their native math, making their reality as self-consistent as ours. Critics argue this blurs the line between abstract and concrete. Does a universe exist if no one perceives it? Tegmark's answer is bold: perception is irrelevant. The Mandelbrot set's infinite complexity existed before humans named it. So too might uncounted mathematical universes, their equations humming in the void regardless of observers. Some physicists counter that without testable predictions, the hypothesis leans toward philosophy, but others see fingerprints in nature's uncanny mathematical elegance, from the fractal branching of trees to the spirals of galaxies. The mathematical universe hypothesis doesn't just expand reality, it redefines it. If correct, then Pythagoras wasn't discovering theorems, he was eavesdropping on the architecture of existence. And somewhere beyond our imagination, a universe runs on equations we'd consider nonsense, its inhabitants equally baffled by our insistence that 1 plus 1 must always only equal 2. Imagine two enormous sheets of paper floating in midair, drifting closer and closer until bang, they smack together with enough force to ignite an entire cosmos. This isn't some art project gone wrong, it's the brain collision universe, a jaw-dropping parallel reality where our entire existence might just be the aftermath of two hyperdimensional membranes crashing together like symbols in the dark. According to string theory, these branes, short for membranes, could be vast, floppy surfaces stretching across hidden dimensions, each one a potential universe unto itself. And if they occasionally collide, that could be the secret origin of Big Bangs, not a one-time event, but a recurring cosmic drumbeat, each strike birthing a new reality. Here's where it gets trippy. Our universe might be stuck to one of these branes like a sticker on a notebook page, a three-dimensional world trapped on a surface that floats through a higher dimensional space we can't see. Think of ants crawling on a tablecloth. They're aware of length and width but have no clue about the third dimension above them. Now picture other tablecloths hanging inches away, each with its own colony of ants, its own stars, planets, and civilizations utterly oblivious to the others. If another brane drifted close enough, we might never know, unless it slammed into us, sparking a new genesis. The math behind this idea comes from the ekpyrotic universe model, which suggests our Big Bang wasn't the beginning, but a reset, a violent encounter between branes that recycled an older cosmos. Unlike the classic explosion from nothing scenario, this theory paints the bang as a collision so colossal, it scattered energy across our brain, forming matter, light, and everything we know. And if it's true, the next collision could be coming not as an end, but another rebirth. Some models even suggest these crashes could be cyclical, happening every trillion years or so, like a cosmic metronome keeping time across eternity. But what about those other branes? Could life exist on them? If string theory's right, adjacent branes might have entirely different physics. One could have 4 dimensions of space instead of 3, making their geometry incomprehensible to us. Another might lack weak nuclear force, preventing atoms from forming altogether. And here's the kicker. Gravity could be the only force that leaks between branes, meaning a civilization right next door might be pulling your coffee cup slightly to the left without ever knowing you exist. Astronomers actually hunt for these ghostly tugs, anomalies in galaxy rotations, or unexplained gravitational ripples that might hint at nearby universes brushing against ours. The most haunting possibility: if a brane collision is due, we wouldn't see it coming. One moment the sky would be normal, the next a wall of pure energy might bloom across the cosmos, rewriting the laws of physics in an instant. But don't panic, these events are likely so rare, humanity will be long gone before the next strike. Or maybe we're living in the brief, shining aftermath of the last one, our entire universe just a temporary spark between collisions. Either way, the brain collision universe doesn't just reshape our past. It hints that reality might be far more crowded, far more chaotic than we ever dreamed. What if the universe only exists because you're looking at it, not metaphorically, but literally, fundamentally, as a rule woven into the fabric of reality itself? This is the spine-tingling premise of the conscious universe, a realm where perception doesn't just record reality, it creates it. And if that's true, then other universes might operate under entirely different rules, shaped by the minds that inhabit them. Picture a cosmos where the color red doesn't exist until someone names it, where atoms refuse to settle into place until observed, or where time itself loops in knots around the gaze of its inhabitants. The roots of this idea stretch back to quantum mechanics' most infamous quirk, the observer effect. In experiments, particles like electrons don't have definite properties until measured. They exist in a haze of probabilities, a state physicists call superposition, only snapping into focus when someone or something pays attention. The classic double-slit experiment shows this beautifully. Shoot particles at a barrier with two slits, and they behave like waves, creating an interference pattern on the other side unless you try to watch which slit they pass through. The moment you observe, the wave-like behavior vanishes as if the particles know they're being watched. Nobel laureate Eugene Wigner took this further, suggesting consciousness itself might be the trigger that collapses quantum possibilities into solid reality. Now extrapolate that to an entire universe. In a conscious universe, the laws of physics might not be written in stone. They could be more like a collective agreement, a cosmic dance between mind and matter. Biocentrism, a controversial theory proposed by scientist Robert Lanza, argues that life isn't just a passenger in the universe, it's the driver. Without observers, reality might be nothing but a fog of unmanifested potential. Trees wouldn't fall in the forest with no one to hear. They might not even be trees until a mind defines them. But here's where parallel universes creep in. If consciousness shapes reality, what happens when different kinds of observers evolve under different conditions? Imagine a universe where intelligent life developed from sonar-sensitive creatures in pitch-black oceans. Their version of physics might prioritize sound over light, with equations describing echoes rather than electromagnetic waves. Or consider a civilization that perceives time as a spatial dimension. Their science could treat the past and future as places you can literally visit, rewriting history not as fiction but as engineering. The most haunting question of all, if a universe begins because of its observers, does it blink out of existence when the last one dies? Philosopher John Wheeler's participatory universe hypothesis suggests the cosmos might be a self-excited circuit, where observation in the present ripples backward to define even the Big Bang's initial conditions. In other words, we're not just living in the universe, we're completing it, like an artist stepping back to finally see the painting they've been creating all along. So the next time you glance at the stars, ask yourself, are you merely a speck in the cosmos, or is the cosmos, in some strange way, waiting for you to speak it into being? The answer might not just redefine reality, it could reveal that every act of perception is a brushstroke on an infinite multiverse canvas, each stroke painting a world entirely its own. Picture the Big Bang not as a single explosion, but as the first firework in a show that never ends, where every burst births new universes, each sparking their own endless showers of cosmic creation. This is the eternal inflation universe, a reality where the frenzied expansion that jump-started our cosmos isn't an event from the past, but an ongoing frenzy, churning out new worlds faster than light can cross them. Like a chain reaction of nuclear blasts in zero gravity, inflation doesn't stop globally, it just pauses locally, leaving behind pockets of calm amid the chaos. And in those calm pockets, that's where universes like ours take root, blissfully unaware of the storm raging beyond their horizons. The genius behind this idea, physicist Alan Guth, realized something startling in the late 1970s. The same mechanism that explains why our universe is so uniform, cosmic inflation's lightning-fast smoothing effect, could also predict infinities upon infinities of other universes. Think of a pot of water boiling violently. Most of the surface froths with bubbles, but here and there patches momentarily settle. Inflation works the same way. Most of the multiverse remains trapped in that hyper-expanding state, but occasionally a region tunnels out to form a stable universe. The catch, the rest keeps boiling, spawning new bubbles endlessly. The result is a fractal foam of realities, each with its own physics, its own history, its own destiny. Some of these universes might be stillborn. Inflation suggests that physical constants, the strength of gravity, the mass of electrons, are determined randomly when a bubble forms. Most combinations would be lethal. Imagine a universe where the strong nuclear force is too weak to bind protons and neutrons. Matter would crumble before stars could ignite. Others might have hypercharged electromagnetism, turning every atom into a magnet powerful enough to shred biological molecules. These are the cosmic dead zones, realms where physics is a suicide note written in equations no life will ever read. Yet amidst the graveyard of failed physics, there are islands of habitability, universes like ours, where the numbers lined up just right. String theorist Andre Lind likens it to walking through a rainforest. Most of the ground is inhospitable mud or rock, but occasionally you find a fruit-bearing tree. The shock isn't that we're here, it's that somewhere, an incalculable number of times over, other versions of here might exist, each with slight tweaks. A universe where dark energy is weaker, allowing galaxies to thrive for trillions of years. Another where the Higgs field is stronger, making atoms, and therefore life, impossibly heavy. The most dizzying implication, eternal inflation, doesn't just suggest a multiverse, it demands one. The equations leave no room for a single, solitary cosmos. And if true, then every possible universe isn't just out there in theory. It's out there in fact, a physical reality in the infinite froth. Your life, your choices, even this exact moment might be playing out in countless variations across the fractal expanse. Somewhere, a version of you is reading these words in a universe where inflation birthed red stars instead of yellow, or where time runs in reverse, or where the very concept of reading never evolved. The kicker, we'll likely never see beyond our bubble. The space between universes stretches faster than light, putting them forever beyond reach. But the math is clear. We're living in a cosmic jackpot, a rare stable clearing in a jungle of runaway creation where most realities are either stillborn or unrecognizable. And the fireworks show isn't stopping, it's accelerating, birthing new universes at a rate so staggering, even infinity needs time to catch up. Flip the periodic table inside out, swap every particle for its polar opposite, and you've got the antimatter universe, a looking glass reality where everything we know is built from antimatter, the rogue twin of normal matter. Here, stars aren't fueled by hydrogen fusion, they burn antihydrogen. Planets aren't rocky spheres of silicon and oxygen, they're sculpted from antisilicon and antioxygen. Even the air, if you could call it that, would be a lethal soup of antinitrogen and antioxygen, ready to annihilate anything made of regular matter on contact. This isn't just a mirrored version of our cosmos, it's a full inversion where the building blocks of existence carry the opposite charge, spin, and quantum quirks. And somewhere in that universe, there's an anti-you sipping anti-coffee, blissfully unaware that a single handshake with your regular matter self would unleash an energy blast rivaling a nuclear bomb. Antimatter isn't science fiction, it's a well-documented reality, just vanishingly rare in our universe. When particles like electrons and protons were first discovered, physicists quickly found their evil twins, positrons, anti-electrons, and antiprotons, identical in mass but opposite in charge. The shock came when they realized these twins obliterate each other on contact, converting their combined mass into pure energy via Einstein's E equals mc squared. So why isn't our universe a barren wasteland of such explosions? After all, the Big Bang should have created equal parts matter and antimatter. The fact that we exist at all hinges on a cosmic fluke called CP violation, a tiny asymmetry in the laws of physics that allowed matter to outnumber antimatter by roughly 1 part in a billion during the universe's first seconds. Every star, every planet, every atom in your body owes its existence to that microscopic imbalance. But in the antimatter universe, the tables are turned. Here, CP violation favored antimatter instead, leaving regular matter as the exotic rarity. Anti-stars would shine just as brightly as ours, their light indistinguishable to the naked eye. Anti-planets would orbit anti-suns, governed by the same gravity since antimatter responds identically to this force. Even anti-life, if it evolved, might look and behave exactly like us. The terrifying beauty of this scenario is that there'd be no way to tell the difference from the inside. Light interacts the same way with antimatter as with matter, so an anti-alien gazing at their anti-night sky would see constellations just as familiar as Orion or the Big Dipper. The only giveaways would be catastrophic. Bring a normal matter apple into their world, and it wouldn't just rot, it'd detonate, unleashing energy equivalent to 43 million tons of TNT per kilogram. This raises a chilling possibility. If antimatter universes exist, they might be closer than we think, trapped in gravitational wells or floating in distant voids, forever separated from us by the one rule that makes coexistence impossible: mutual annihilation. Some theories even suggest that antimatter black holes could lurk in our cosmos, their event horizons hiding entire anti-galaxies within, the universe's greatest irony. The very thing that makes antimatter fascinating, its explosive potential, also ensures we'll likely never visit, touch, or even confirm these twisted reflections of reality. For now, they remain the ultimate cosmic doppelgängers, perfect in every detail and perfectly lethal to us. Imagine watching a drop of ink diffuse through water, except instead of spreading out, the swirling tendrils snap back together, gathering into a single dark pinpoint. This is the low-entropy universe, a place where disorder doesn't increase over time, it decreases. Here, the second law of thermodynamics runs in reverse, making time itself seem to flow backward. Coffee cools by drawing heat from the air, shattered glass leaps back into whole panes, and memories aren't records of the past, they're premonitions of the future. If that sounds like a physicist's fever dream, buckle up, because this universe might be more plausible than you think. Entropy is the universe's way of keeping score, a measure of chaos that always climbs higher, from the moment hot tea steams into the air to the far future when stars burn out and black holes evaporate. But in this mirrored reality, entropy ticks downward instead. Think of an ice cube melting in reverse. Puddles gather into perfect cubes, water molecules aligning with eerie precision as heat rushes into the surrounding air. Thermodynamically, this isn't impossible, just staggeringly unlikely, like shuffling a deck of cards into perfect numerical order by chance. Yet in the low-entropy universe, this isn't a fluke, it's the baseline. For hypothetical beings living there, existence would feel utterly alien. Their brains wouldn't store memories of the past, they'd anticipate the future, with each moment revealing what's already predetermined. Picture waking up knowing exactly what you'll do tomorrow, but with no recollection of yesterday. Conversations would sound like playback in reverse, responses coming before questions, laughter before jokes. Even aging would defy logic. Corpses would reassemble in graves, rising younger with each passing year until they gasped back to life. To them, this wouldn't feel bizarre, it'd be as natural as sunrise is to us. Scientists debate whether such a universe could sustain life. Some argue decreasing entropy would prevent complex structures like DNA from forming. Others counter that life might adapt, exploiting the reverse flow to remember future events as instinctively as we recall the past. Imagine a tree growing from scattered leaves and sunlight, its roots retreating into a seed, or a civilization building skyscrapers by disassembling rubble into pristine steel beams. Their science might treat the Big Bang as an end point, their cosmos collapsing toward a singularity of perfect order rather than expanding into chaos. Here's the twist: our own universe might have begun in a similarly improbable low-entropy state. Physicists still grapple with why the early cosmos was so ordered, a mystery called the past hypothesis. Some speculate a higher dimensional process set the initial conditions. Others wonder if entropy's arrow is just an illusion, a local quirk in a multiverse where time's flow varies wildly. If true, the low-entropy universe isn't just a thought experiment. It's a haunting glimpse into how fragile our experience of cause and effect might really be. So the next time you watch steam rise from your coffee, consider this. Somewhere, a version of you might be watching that steam dive back in, their reality rewinding toward a moment when every atom in the cosmos snaps into perfect alignment, a beginning that, to them, looks exactly like an end. Pause your watch, silence every ticking clock, and try to grasp this time as you experience it might be nothing more than an illusion. The no-time universe flips everything we think we know about existence on its head. Here, reality isn't a flowing river but a frozen sculpture, where every moment from the Big Bang to the heat-death of the cosmos exists simultaneously, like frames etched permanently onto a cosmic film reel. Your birth, your first kiss, the moment you're hearing these words right now, they're not passing events, they're fixed points in an infinite block, as unchanging as landmarks on a map. This isn't just wild speculation. Einstein's theory of relativity paved the way for this mind-bending view. Space-time, in his equations, is a four-dimensional tapestry where now is as arbitrary as here. Just as you wouldn't argue that New York is more real than Tokyo because you're standing in it, relativity suggests the past and future aren't less real than the present. They're elsewhere in the block, philosophers call this eternalism, the idea that time is a dimension like space, where you are just one slice of a much larger, unchanging entity. Think of your life as a DVD. The entire movie exists at once, even though you only experience one scene at a time. Now, imagine living in a universe where everyone knows time doesn't flow. Causality, the idea that events cause other events, would feel like a strange myth. A future version of you already exists, complete with memories of this exact moment, just as a past version is frozen mid-laugh at a joke they haven't heard yet. Free will would take on a bizarre new meaning. Your choices aren't decisions you make, they're features of the block, as predetermined as the contours of a mountain range. It's like reading a novel where the ending is already written, but you're still turning pages, discovering it line by line. Critics argue this view drains life of its urgency, but proponents see eerie beauty in it. If every moment is equally real, then nothing is ever truly lost. The dinosaurs still roar in their stratum of space-time. Marilyn Monroe's laugh echoes in hers. Grief and nostalgia become matters of perspective, like missing a place you've left, even though it still exists on the map. Some physicists even suggest quantum entanglement, where particles instantly influence each other across vast distances, hints at this timeless reality, with spooky action at a distance making sense if past and future are secretly adjacent. The no-time universe doesn't just reshape how we see clocks, it rewrites what it means to exist. You're not a fleeting spark, you're a thread woven permanently into the cosmos's fabric. And somewhere in that frozen block, another version of you is pausing, just like this, to wonder if time was ever moving at all. Take a deep breath and step into a world where reality itself has been stretched, where the tiniest building blocks of existence are no longer hidden from view. This is the giant universe, a place where the Planck length, the smallest possible unit of space, isn't microscopic but magnified to the scale of everyday objects. Here, quantum weirdness isn't confined to labs or equations. It's your daily commute. Imagine reaching for a doorknob, only for your hand to slide right through it as if the atoms themselves were merely suggestions. Or watching coffee particles teleport from your mug to the counter, vanishing and reappearing in a blink. In this cosmos, the fundamental fuzziness of quantum mechanics isn't a curiosity. It's a tactile, visible part of life. The Planck length in our universe is absurdly small, a trillionth of a trillionth the size of a proton. But in the giant universe, it could be as large as a grain of sand. Suddenly, Heisenberg's uncertainty principle isn't just a quirk of physics. It's the reason your morning commute feels like navigating a funhouse. Objects flicker between states, never fully solid or stable. You might sit on a chair only to find yourself suddenly on the floor as its particles momentarily lose cohesion. Light doesn't travel in smooth waves, it stutters like a strobe, casting jumpy shadows that flick between positions. Even sound would behave bizarrely, with echoes arriving before the original noise as quantum fluctuations scramble cause and effect. Now flip the script. Picture a universe where the Planck length is unimaginably smaller, shrunk so dramatically that atoms balloon to the size of galaxies. In this tiny universe, the emptiness of matter becomes staggeringly apparent. A single hydrogen atom would dwarf our solar system, its lone electron orbiting a proton like a distant moon. The air around you wouldn't feel like air at all. It'd be a sparse void where particles drift light years apart. Chemistry, as we know it, would be impossible. Molecules couldn't form, leaving this cosmos a barren, frozen wasteland. Stars and planets couldn't coalesce. Gravity would be far too weak to pull these gargantuan atoms together. The night sky wouldn't twinkle with distant suns. It'd be a pitch-black expanse, punctuated only by the occasional, lonely glow of a single electron transitioning between orbits over millennia. The contrast between these two extremes reveals just how finely tuned our own universe is. If the Planck length were even slightly larger, reality would dissolve into chaos. Any smaller, and the cosmos would be too vast and empty for structure, let alone life, to emerge. It's as if the universe threaded a needle, balancing on a razor's edge to allow galaxies, planets, and conscious beings to exist. The giant universe shows us what happens when quantum uncertainty spills into the macro world. The tiny universe reminds us how fragile the scaffolding of reality truly is. Somewhere out there, these cosmic oddities might exist, realms where the fundamental rules of scale rewrite the very experience of existence. And in those places, the inhabitants wouldn't find their world strange at all. To them, our universe where particles stay put and doors remain solid might seem like the impossible dream. Every breath you take, every step you walk, every sunrise you witness, all of it depends on a dizzying array of cosmic coincidences so precise they defy belief. Gravity's strength, the charge of an electron, the nuclear forces binding atoms together tweak any of these even slightly, and life as we know it would be impossible. But what if we're not living in the most hospitable universe? What if somewhere out there, reality hit the jackpot even harder, crafting conditions not just adequate for life but optimized for it? This is the life-friendly universe, a realm where the dials of physics are tuned to perfection, creating a paradise of biological possibility. Picture a planet no larger than a city, yet with Earth like gravity. Sounds impossible, right? In our universe, gravity is weak, so feeble that it takes an entire planet's worth of mass to keep your feet on the ground. But in the life-friendly universe, gravity could be 10 times stronger, compressing rocky worlds into dense, tiny spheres. These super-Earths might have continents stacked like pancakes, their steep gravity wells creating towering, slender mountains and deep, narrow oceans. Life there wouldn't need vast territories to thrive. A single valley could host ecosystems as diverse as an entire continent on Earth. Trees might grow stouter and tougher to withstand the relentless pull, while animals evolve compact, muscular frames. Imagine hummingbirds the size of ants, flitting between flowers no bigger than pinheads, all thriving in a world where physics encourages complexity at miniature scales. Now consider the stars. Our sun burns for billions of years, a cosmic fluke that allows life enough time to evolve. But in the life-friendly universe, stellar physics could be even kinder. Fusion rates might be perfectly calibrated to make stars burn slower and steadier, their lifespans stretching for trillions of years. Planets orbiting these gentle giants would bask in stable, eternal sunlight, their climates unchanging for epochs long enough to nurture intelligence not once but repeatedly across vast stretches of time. Civilizations could rise, fall, and rise again, each iteration building on the ruins of the last without the existential threat of their sun dying. This raises a haunting question. If such a paradise exists, why aren't we there? The anthropic principle offers a chilling answer. It suggests we find ourselves in this particular universe not because it's the best possible one, but because it's the only kind where beings like us could arise to ponder the question. Universes with stronger gravity might be lush with life, but if their stars burn too fast or their chemistry is unstable, no one's around to notice. Ours is a cosmic balancing act, a good enough reality where the constants are just barely within the narrow window for life to squeak by. Yet the life-friendly universe lingers in our imagination like a dream of Eden. It challenges us to ask, is our existence a happy accident, or is there something deeper at work? And if perfection is possible somewhere in the multiverse, what does that say about our own universe's untapped potential? The answers might not just redefine life's place in the cosmos, they could hint that even in a sea of infinite possibilities, we're clinging to a raft in the storm, while somewhere a luxury cruise sails on calmer waters. Not every universe gets the privilege of life or even the building blocks for it. Imagine a cosmos where the fundamental forces are so misaligned, atoms can't form stable bonds, stars never ignite, and the very concept of chemistry is an impossible dream. This is the no-life universe, a desolate expanse where reality's dials were set to sterile from the start. Here, the strong nuclear force, the glue that binds protons and neutrons in atomic nuclei, might be just a fraction weaker or stronger than in our world. That tiny tweak would rewrite the rules of existence itself, leaving the cosmos frozen in a state of perpetual simplicity. Take carbon, the backbone of all known life. Its existence hinges on a delicate balancing act called the triple alpha process, where stars fuse helium nuclei with pinpoint precision. If the strong force were even 5% weaker, protons would repel each other too fiercely for this process to occur. No carbon means no DNA, no proteins, no organic molecules, just a sea of hydrogen and helium floating forever in the dark. On the flip side, if the force was slightly stronger, all hydrogen would have fused into heavier elements during the Big Bang, leaving no fuel for stars to burn. The result, a universe without sunlight, heat, or the long-lived stable stars that nurture planets. In both scenarios, the cosmos becomes a cosmic stillbirth, its potential snuffed out before complexity can even whisper. Our universe's fragility becomes starkly clear when you examine water, a substance so ordinary to us, yet a miracle of physics. The hydrogen bonds between water molecules depend on electromagnetic forces balancing just right. Nudge those forces even slightly and ice wouldn't float, rivers wouldn't flow, and the delicate dance of solvents that makes cellular chemistry possible would collapse. The no-life universe isn't just devoid of creatures, it lacks the very conditions for anything more intricate than scattered subatomic particles. No swirling galaxies, no molten planetary cores, no thunderstorms or tidal pools, just a thin, inert haze of matter drifting through endless night. Even time behaves differently in such a place. Without heavy elements forged in stellar furnaces, there are no radioactive isotopes to heat planetary interiors. Earth's molten core, which generates our protective magnetic field, would never exist. Solar systems would be stillborn, their planets cold and geologically dead. And without plate tectonics to recycle minerals or volcanic vents to concentrate chemicals, the spark of life would have no kindling. The no-life universe isn't merely uninhabited, it's architecturally incapable of hosting complexity at any scale. Yet here we are, in a cosmos where the numbers lined up just right. The strong force binds nuclei without stifling fusion. Electromagnetism allows chemical diversity without making bonds unbreakable. Gravity is weak enough to let planets form, but strong enough to ignite stars. This cosmic lottery win is so improbable, some physicists propose a multiverse to explain it, a vast array of universes where most are barren, and we just happen to occupy the one where the dice rolled in life's favor. The no-life universe isn't science fiction, it's the statistical norm. Our reality, with its lush biospheres and twinkling starlight, might be the exception, a single fertile oasis in an infinite desert of silent emptiness. That realization casts our existence in a haunting new light. Every tree, every breath, every thought is the product of constants so finely tuned, even a slight deviation would erase them all. The no-life universe isn't just a cautionary tale, it's a mirror showing us how breathtakingly rare, how fragile, and how precious our place in the cosmos truly is. Somewhere in the vast cosmic tapestry, there's a version of you wearing an eye patch and a space helmet, swashbuckling through the asteroid belt. Sounds absurd. Not in the infinite clone universe, a reality where every possible iteration of you exists, from the mundane to the utterly fantastical. Thanks to the sheer scale of infinity, every choice, every chance encounter, every roll of the dice spawns a new timeline where your life veers in a different direction. The math behind this isn't just speculative, it's a staggering inevitability. If the multiverse is truly infinite, then somewhere, a version of you just won the lottery with numbers they scribbled on a napkin. Another is currently ruling a tiny island nation as a philosopher king. And yes, somewhere out there, pirate astronaut you is definitely real, grappling with zero-gravity sword fights and solar sail heists. Physicist David Deutsch, a pioneer of quantum computation, frames this as the ultimate expression of the multiverse. In his vision, every quantum decision point, every particle's spin, every atom's vibration splits reality into alternate branches. But here's the twist, these branches aren't just minor variations. Given enough time and enough quantum dice rolls, they encompass every logically possible configuration of existence. The key word, logically. Pirate astronauts might stretch our imagination, but they don't break the laws of physics. A universe where you turned left instead of right at a crossroads is trivial. One where you're a cyborg cowboy herding genetically engineered space bison, still on the table. The only limit is what physics permits, not what feels plausible to your earthbound brain. Let's crunch the numbers. Imagine every second of your life presents just 10 meaningful choices. By the end of a single day, that's 86,400 alternate versions of your existence. Over a lifetime, the possibilities outnumber the atoms in the observable universe. Now factor in every human, every organism, every particle's quantum state across infinite space and time. The result is a multiverse so densely packed with variations, it guarantees not just one pirate astronaut you, but an infinite legion of them, some with robot arms, others with alien co-pilots, all equally real in their respective timelines. This raises a haunting question. If countless versions of you are living out every conceivable life, what does that mean for this version? Free will starts to feel like an illusion, a script already written in every possible way. But Deutsch offers a liberating perspective. In the quantum multiverse, you are the common thread weaving through these branches. Every decision isn't about erasing paths, but about selecting which branch you consciously experience. The you reading this now isn't more or less real than the one who skipped this video to binge baking shows. You're just on different frequencies of the same cosmic broadcast. Yet the infinite clone universe isn't just about you. It reshapes how we see history, morality, even identity. Every tragedy averted in one world unfolds catastrophically in another. Every act of kindness you hesitated to perform, somewhere a version of you followed through. The weight of this knowledge isn't paralyzing, it's electrifying. If every possibility exists, then the version of reality you choose to inhabit matters, not because it's the only one, but because it's the one you're here to shape. So while pirate astronaut you is off plundering nebulae, you've got your own adventure unfolding, one where the next choice, however small, spins off a universe all its own. What if the reason you can't break the speed of light isn't a law of physics but a hardware limit? Not in our world, but in the universe of whoever's running ours. This is the virtual reality universe, where reality as we know it might just be an ultra-advanced simulation created by beings so far beyond us. We're nothing more than background characters in their cosmic sandbox. Think of it like the Matrix, but with a terrifying twist. There's no red pill to wake you up, no glitches in the code to reveal the truth. Because in this scenario, the simulation is so flawless, even the scientists probing the fabric of reality are just programmed to think they're discovering something new. The concept isn't as far-fetched as it sounds. Right now, we're building rudimentary virtual worlds, video games with NPCs who follow scripts, AI chatbots that mimic human conversation. Now project that forward 1,000,000 years. A civilization with quantum supercomputers could simulate entire universes atom by atom, tweaking the laws of physics like game settings. To them, our suffering, our joy, our existential dread might be as meaningful as the drama unfolding in a Sims household when you turn off the computer. Even the speed of light, that ultimate cosmic speed limit, could just be their processor's max render rate, a buffer to prevent the simulation from lagging when too many particles move at once. Here's where it gets eerie. If we are living in a simulation, certain quirks of quantum mechanics start to make unnerving sense. Why do particles exist in multiple states until observed? Maybe because the simulation only renders them when needed, conserving processing power like a video game that doesn't load the entire map until the player walks into a new area. Ever experienced déjà vu? That could be a memory leak, a fleeting glimpse of code repeating itself. Even the infamous double-slit experiment, where particles behave differently when watched, mirrors a game optimizing graphics based on whether anyone's looking. But the real gut punch, there's no way to know for sure. A sufficiently advanced simulation wouldn't leave obvious glitches, it'd patch them before we noticed. Some physicists argue that if our creators didn't want us to figure it out, they'd have coded the universe to appear perfectly natural with no backdoor escapes. The red pill from the Matrix is a fantasy. Here, the walls of the cage are seamless. You could spend your life searching for proof and never find it, because every tool you use, every microscope, every equation, is just more simulated code. Yet this theory forces us to ask a profound question. Does it matter? If emotions feel real, if starlight burns your eyes just as brightly, is reality any less meaningful because it's made of math instead of matter? Maybe the virtual reality universe isn't a prison, it's a challenge. To live fiercely, love deeply, and explore relentlessly, even if we're just bits in some alien child science project. After all, if you were the simulation's architect, wouldn't you be thrilled to see your creation staring back at the code, trying to understand you? Picture a world where sunsets still blaze in fiery oranges and purples, where laughter echoes through crowded streets, where pain flares just as sharply, but behind every pair of eyes there's nothing. No one actually sees those colors, hears those sounds, or feels that pain. This is the zombie universe, a reality physically identical to ours in every way except one. It's completely devoid of conscious experience. The people here aren't brainless husks. They walk, talk, and even debate philosophy like any human. But their inner world, a perfect void. no joy, no sorrow, no awareness whatsoever. They're philosophical zombies functioning flawlessly without ever truly experiencing a single moment. The idea comes from David Chalmers' notorious hard problem of consciousness, the question of why and how subjective experience arises from physical processes. In our universe, when you stub your toe, neurons fire, signals race to your brain, and you feel the sting. But in the zombie universe, those same neurons fire, the same signals race, and nothing happens inside. The zombie version of you still yelps and hops on one foot, cursing the coffee table. It might even say it feels pain, but there's no light on upstairs. No one's home. Could such a universe actually work? At first glance, yes. Zombie, you would pass every Turing test, ace every job interview, even write heartfelt poetry, all without ever grasping what sadness or beauty is. Their bodies would react to threats, seek pleasure, and avoid harm through pure biochemical autopilot. But dig deeper and paradoxes emerge. Without genuine fear, why would a zombie flee a predator? Without real desire, why would it chase a promotion? Our emotions and senses aren't just decorations, they're the engine driving decision-making. Strip them away, and behavior becomes a hollow script with no director. This raises a chilling question about our own reality. How do you know the people around you aren't zombies? Maybe you're the only conscious being in existence, surrounded by sophisticated meat robots. Philosophers call this solipsism, and there's no way to disprove it, but the zombie universe pushes further. If consciousness doesn't affect physical behavior, since zombies act identically to us, then by definition, it doesn't do anything. And if it's causally inert, why did evolution bother with it at all? Now, pivot to AI, the modern twist on this ancient riddle. Today's chatbots can mimic human conversation so well, they often fool us. But do they understand a single word they say? If we one day build a robot that perfectly simulates a person, will it be a marvel of engineering or the first true philosophical zombie? Some argue consciousness requires biological wet-ware, the messy, organic dance of neurons. Others insist it's about complexity. Once a system reaches a certain threshold of information integration, boom, lights on. The scary part, we might create a zombie universe inside a supercomputer and never realize it, filling servers with countless suffering minds that scream into a void no one can hear. The zombie universe doesn't just challenge our place in reality, it asks whether reality needs us at all. If a world can run perfectly without consciousness, then what's the point of qualia, the raw feel of experience? Is it the universe's way of keeping score, or just a bizarre glitch in ours? One thing's certain, in a multiverse of infinite possibilities, there's likely a version of Earth where this script is being read aloud right now to an empty room full of nodding, unseeing faces. You wake up, yawn, and check your phone, same date as yesterday. The radio plays the same song. The same stranger spills coffee on you at the exact same intersection. At first, it's eerie, then terrifying. Then, after a few thousand repetitions, it's just existence. Welcome to the time loop universe, where reality isn't a straight line but a Möbius strip, bending back on itself endlessly. Here, every laugh, every tear, every cosmic event from the Big Bang to the last black hole's evaporation is destined to replay in perfect sync, like a record stuck on repeat. This isn't just sci-fi, it's a legitimate cosmological model. Closed time-like curves, solutions to Einstein's equations, allow time to loop back on itself, creating a universe where the future is the past. Picture a roller coaster that twists so sharply, the last car collides with the first, except the cars are moments in time, and the collision is your birth smashing into your death. Philosopher Friedrich Nietzsche called this eternal recurrence, suggesting that if time is infinite, every possible configuration of matter must recur infinitely. Your joy, your regrets, even this exact thought, you've lived it before, and you'll live it again in precisely the same way. But here's the gut punch. If the loop is flawless, can you really choose differently? In Groundhog Day, Bill Murray's character eventually learns piano and selflessness, breaking his personal cycle. But a true time loop universe offers no escape hatch. Your choices are just echoes of actions you've already taken, replaying like programmed steps in a cosmic dance. Free will becomes an illusion, a script you're convinced you're writing, even as you trace the same lines for the billionth time. The coffee spills because it always spills. You react with annoyance because you always react with annoyance. The universe isn't just predictable, it's a prison of inevitability. Critics argue this violates quantum randomness, but some physicists propose that even quantum fluctuations could reset identically in each cycle. Imagine shuffling a deck of cards endlessly. Given enough repeats, the same shuffle must recur. Now scale that to every particle in existence. Even stranger, if the loop is truly perfect, you'd never know. Memories reset with each cycle, leaving no trace of the repetitions. The déjà vu you felt yesterday, just a glitch in the cosmic replay. Yet the time loop universe isn't just bleak, it's weirdly poetic. If every moment is fated to recur, then every act carries infinite weight. The kindness you show today ripples across eternity, replaying forever. The cruelty you avoid saves you from reliving it infinitely. Nietzsche saw this as the ultimate test of character. Live as if you'd have to relive this life eternally. In a multiverse of endless possibilities, the time loop universe is the haunting counterpoint, a reminder that even infinity can feel claustrophobic, and that the most terrifying prison might be a perfect repetition of the life you're living right now. Consider a cosmos so vast, so unimaginably diverse, that every conceivable version of reality, no matter how bizarre, must exist somewhere within it. This is the ultimate ensemble, physicist Max Tegmark's Level 4 Multiverse, where the only limit to existence is logical consistency itself. Not just variations of our physics, not just branching timelines or bubble universes, but every mathematically possible structure playing out in parallel. Here, universes aren't bound by laws we'd recognize. Gravity could be a side effect of nostalgia. Time might unspool in Hakus. There could be a dimension where the concept of left tastes like raspberries, or another where the number 7 is literally unlucky. Trip over it and it might bite. Take something as mundane as pudding. In our universe, it's a dessert. In the ultimate ensemble, there's a reality where it's the fundamental fabric of space. Stars aren't balls of plasma, they're swirling vortices of vanilla custard. Planets condense from chocolate mousse, orbiting whipped cream suns in a cosmic bakery. Sentient beings there don't wonder about atoms, they ponder the mysteries of thickness and wobble. Absurd, absolutely, but in a level 4 multiverse, if the math checks out, it's as real as the phone in your hand. Language takes on a surreal twist in other corners of this infinite mosaic. Picture a world where words aren't symbols, they're physical objects. The sentence, "It's raining cats and dogs," would require storm shelters for falling nouns. Love letters could be literal bricks, their weight proportional to the emotions they carry. Shakespeare's plays might sprawl across the landscape like architectural wonders, with Hamlet's soliloquy forming a bridge between continents. Even this script you're hearing would materialize as a fragile origami sculpture, folding and unfolding in midair. The ultimate ensemble doesn't just tolerate weirdness, it demands it. Somewhere, a universe runs on rules where procrastination generates energy. The more you delay, the brighter your cities glow. Another operates entirely in rhyme, with cause and effect adhering to iambic pentameter. Want to turn on a light? Better say, illuminate this room with fiery might. Stumble, and the universe stumbles with you. Lights flicker in confusion until you nail the meter. Tegmark's radical proposition shifts the multiverse from a scientific hypothesis to a metaphysical inevitability. If reality is fundamentally mathematical, not just described by math but made of it, then any self-consistent equation must correspond to a physical universe. No creators, no simulations, just pure abstraction manifest as existence. The ultimate ensemble doesn't care if a universe seems silly or sublime. It doesn't judge whether a reality where clouds sing opera is useful or likely. If the numbers work, the cosmos clicks into being. This forces a profound reframing of our place in the grand scheme. Our universe, with its tidy laws and predictable orbits, isn't special. It's just one page in an infinite library where the books are written in geometries we can't pronounce. Somewhere, a version of you is a sentient fractal, pondering whether Euclidean creatures like us are mathematically possible. Another is a theorem in a universe made of pure logic, where thinking means rearranging cosmic parentheses. And yes, somewhere, there's a reality where you did actually remember to put your keys in the same spot every day. The ultimate ensemble is the final rebuttal to the idea that reality must make sense to us. It declares that the cosmos owes no explanations, no justifications, only consistency. So the next time you encounter something inexplicable, take comfort. In another universe, it's Tuesday. From bubble universes floating in an endless cosmic froth to infinite clones of yourself swashbuckling through alternate timelines, we've journeyed through 25 realities that defy everything we thought we knew about existence. Each one stretches the imagination in wildly different directions, whether it's the holographic universe projecting reality from a two-dimensional edge, the Boltzmann brain conjuring your entire life from a random flicker in the void, or the ultimate ensemble where every mathematically possible cosmos, no matter how absurd, becomes real. These aren't just thought experiments, they're windows into a multiverse so vast, so strange, that our ordinary lives might be the exception rather than the rule. Think about it. In one universe, you're sipping coffee while dinosaurs roam outside your window. In another, you're made of antimatter, annihilating anything you touch. Somewhere else, you're a character in an alien's video game, or a fleeting pattern in a timeless block where past and future exist simultaneously. The sheer variety isn't just humbling, it's liberating. Reality might not have a single right version. Instead, it could be a kaleidoscope of possibilities, each with its own rules, its own beauty, its own nightmares. But here's the real kicker: these ideas aren't just science fiction. They're grounded in cutting-edge physics, from the equations of quantum mechanics to the mind-bending math of string theory. The fact that brilliant minds take them seriously should make us all pause. What if our universe is just one verse in a grand cosmic poem, with stanzas we're only beginning to decipher? So now it's your turn. If you could step into any of these 25 universes just for a day, which would it be? The life-friendly universe with its paradise planets, or the mirror matter universe where left is right and up is down? Maybe you'd brave the time loop universe to see if you could finally break the cycle, or dive into the mathematical universe where numbers sculpt reality itself. Drop your pick in the comments below. We're dying to hear which cosmos calls to you. And if your brain's still buzzing from these cosmic mysteries, hit like and subscribe for more deep dives into the unknown. The multiverse is vast after all, and we've only just begun to explore